you submitted a really fascinating paper for us to take a look at
Yeah.
from Google DeepMind. And
I like one.
it really is. It's all about LLMs and whether they can actually reason without explicit prompting.
Yeah, definitely hot topic right now.
It is. We're going to unpack how these models handle complex problems
Okay.
and what this all means for the future of AI.
Sounds good.
This is super important
Yeah.
because if we can figure out true reasoning in AI, the applications are kind of endless,
Yeah, for sure.
from speeding up scientific discoveries to completely changing the way we solve problems every day.
Totally. I think this paper really gets at the core of that idea of intrinsic reasoning in these LLMs.
Yeah.
And I think it challenges a lot of the assumptions we have about how they learn
Yeah.
and how they process all this information that we feed them.
So the big question the researchers are tackling is, can LLMs reason without all the fancy prompting techniques we use?
Right.
What happens when we just give them a problem straight up? No hand-holding?
It's like we're trying to see if they can think for themselves.
Right.
You know, like, can they come to those conclusions without us leading them there step by step?
So can they problem solve
Exactly.
like a person would?
Yeah, and the researchers actually found that they can reason without those instructions,
Right.
but it's not always super clear
Oh, okay.
because of how we typically get output from them.
So remind me, what's decoding again in this context?
Decoding is essentially how we get the LLM to generate text.
Yep.
And the standard ways we do this prioritize the most likely next word, and that often leads to really quick and direct answers.
Okay.
But sometimes those answers aren't right,
Yeah.
especially when the problem requires more thought.
More of a process.
Yeah.
Yeah.
So it's kind of like the LLM is jumping to a conclusion
Right.
without showing its work.
Okay.
It might be thinking through the steps, but we don't really see that in the final output.
It's like in school when you just put the answer down and the
Exactly.
teacher's like, how'd you get there?
Right, exactly. You gotta show your work.
Show your work.
That's kind of what we're trying to get at here with LLMs.
Interesting.
We want to see those steps.
Right.
So it seems like it's focusing on what's the most probable answer
Okay.
based on its training rather than actually thinking through the problem.
So it's not really problem solving.
Yeah, not in the way that we typically think about it.
Interesting.
But here's where it gets really cool.
Okay.
Buried within those less likely decoding paths, the ones that often get ignored,
Yeah.
are these things called chains of thought.
Ah, CoTs.
Yeah.
So we're talking about those logical steps,
Right.
the step-by-step breakdown of how it's reasoning.
Exactly.
Right.
And the fascinating thing is that these chains of thought, even though they're not the most obvious path,
Yeah.
often lead to the right answer.
It's like they have the ability to think logically,
Yeah.
but they're just not using it.
Right. Or at least not showing us that they're using it.
Okay. So how do we get these chains of thought to the surface?
Right. That's the million-dollar question.
Right.
So in the paper, they illustrate this by looking at how an LLM tackles two problems.
Okay.
One is a simple math problem, and the other is trying to figure out if someone was born in an even or odd year.
Okay.
It's called a year parity problem.
Interesting.
Sounds simple enough.
Yeah.
But it requires a specific chain of thought.
Okay. Let's use that math problem as an example.
Sure.
What was the actual problem?
The problem was, I have 3 apples. My dad has 2 more apples than me.
Right.
How many apples do we have in total?
Oh, that's easy.
Yeah, seems pretty straightforward.
Yeah.
But using standard decoding, the LLM just answered 5.
So it just took a shortcut.
Yeah, it went for the most likely next word at each step and completely missed the actual logic of the problem.
So no gold star for that one.
No gold star for the LLM on that one.
But I'm sure the researchers found something interesting
Yeah.
when they looked at those less likely decoding paths.
This is where it gets exciting.
Okay.
They found paths where the LLM actually reasoned correctly.
Oh, wow.
Like it was actually thinking through the steps.
That's pretty cool.
One path showed the LLM thinking, my dad has 5 apples and I have 3 apples, so we have 8 apples in total.
Okay.
So it actually figured out how many apples the dad had and then added them together.
Okay, so it actually did the math.
It did the math.
It's kind of mind-blowing.
It is. It's like a glimpse into how these models might actually be thinking.
Yeah.
There was another path where it reasoned from your perspective, and it said, you have 3 apples. Your dad has 2 more apples than you. So he has 3 plus 2 equals 5 apples. Together, you have 3 plus 5 equals 8 apples.
So it's like trying to teach someone how to solve the problem.
Right. It's laying it all out there step by step.
Yeah.
And I think that's a really important point.
Yeah.
You know, if we can understand this ability and really harness it, imagine what that could mean for education, for
Yeah.
knowledge transfer.
Wow.
It's pretty wild.
Yeah. But it sounds like it's a challenge to actually get those CoTs out there
Oh, absolutely.
because they're not always front and center.
Yeah. They're kind of hidden
Right.
in all that data.
So how do the researchers deal with that?
Well, they developed a method that they call CoT-decoding.
Okay.
And it's all about focusing on the LLM's confidence in its final answer.
So the higher the confidence,
Yeah.
the more likely it is that it actually used a valid CoT to get there.
Exactly. It's like the LLM is saying, hey, I'm pretty sure this is right because I thought it through really carefully.
Like I didn't just guess this.
Yeah, it's like I have reasoning to back this up.
I did the work.
Yeah.
That's cool.
So that's kind of the basis of CoT-decoding, and we'll dig into the results of that
Okay.
and what that means in a bit.
Great. Awesome. I'm excited.
And the results they got were pretty amazing.
Oh, really?
Yeah, CoT-decoding actually increased the accuracy.
Yeah.
Across different LLM sizes,
Okay.
different families like PaLM-2, Mistral, even Gemma.
So it wasn't just like one particular type of LLM.
No, it seems like it's something more fundamental.
Yeah, like how they reason.
Exactly.
It's really interesting that they also tested CoT-decoding on instruction-tuned models.
Yeah, that was a really interesting part of the research.
Because you'd think if they've already seen chains of thought,
right,
they wouldn't really need it.
You would think so, right?
Yeah, so why do they still need CoT-decoding?
Well, it turns out, even though they're trained on all these step-by-step examples, they still sometimes try to answer directly.
Oh, wow.
Without going through all those reasoning steps.
Really?
Yeah, it's kind of like they're falling back on old habits.
So even with specific training,
yeah,
they might still take shortcuts.
Right.
And then the CoT-decoding kind of keeps them in check.
Exactly.
Makes them use those skills.
Yeah, it's like a safeguard.
It's interesting because it makes you think that maybe instruction tuning isn't teaching them completely new skills.
Right.
It's just making the ones they already have more likely.
Yeah, it's like it's highlighting those paths.
Okay.
Making them more prominent.
So CoT-decoding's like, hey, remember that logical thinking you can do?
Yeah.
Use it.
Exactly.
That's kind of a cool way to think about it.
Yeah, that analogy.
So if LLMs can reason without prompting,
yeah,
why do we even need prompting?
That's a great question, and the paper actually gives us some clues about that.
Okay.
It seems like the difficulty of the task really plays a role in how easily the LLM can access those reasoning paths.
So for simpler tasks, those correct paths are there.
They are.
They're just maybe not as obvious.
Yeah, they might be buried a little deeper.
And prompting helps kind of bring them out.
Yeah, it's like giving them a little nudge
right.
in the right direction.
But as tasks get more complex,
right.
Especially the ones that are very artificial or require lots of steps, finding those reasoning paths becomes way harder.
It does.
Even with CoT-decoding.
Even with CoT-decoding.
So this suggests that LLMs still struggle with certain kinds of complex reasoning.
Yeah, that's a really important point.
Like keeping track of lots of information or understanding subtle relationships.
Absolutely. It seems like that's where they really hit their limits.
So in those situations, maybe prompting is more about teaching them a new strategy.
Yeah.
Not just reminding them of something they already know.
It's a really crucial distinction, and it helps us understand, when prompting is actually necessary.
I think that this research does a good job of showing what LLMs are learning from data versus what we're guiding them towards with prompts.
Absolutely. It's like we're finally getting a glimpse into how their minds work.
Yeah.
It's pretty exciting.
It's kind of like peeking behind the curtain.
Exactly.
So that's really important for developing better LLMs.
Absolutely.
And for understanding what their true potential is.
It's essential if we want to use them responsibly and ethically.
Okay, so it seems like they are capable of reasoning.
Yeah.
More so than we thought.
More than we initially thought.
But we just need better ways to get to that potential.
And CoT-decoding seems like a really promising avenue.
It does.
But it's really just the beginning.
Okay.
There's so much more we need to uncover.
I agree. I'm curious about how CoT-decoding might work with the more traditional prompting techniques.
Yeah, that's a really good question. And the paper actually delves into that a bit.
Okay.
It's not really a question of one or the other. It's more about how we can use both effectively.
So prompting and CoT-decoding aren't mutually exclusive.
Exactly. They can work together.
Okay.
And actually, the researchers found that combining zero-shot CoT prompting, where you just tell the LLM to think step by step, with CoT-decoding led to some really significant improvements.
Oh, wow. So it's like the prompting sets them up to think in that way.
Yeah.
And then the CoT-decoding makes sure they actually do it.
Exactly. It keeps them on track.
That's really cool.
Yeah. It's a powerful combination.
It's interesting because they found that this combo actually outperforms self-consistency.
Yeah, that was a surprising finding.
Remind me what self-consistency is again?
So self-consistency is a technique where you basically generate multiple responses from the LLM.
Okay.
And then you pick the one that's the most consistent.
Oh, okay.
It's a way of trying to get the best possible answer.
It sounds pretty effective.
It can be.
So why didn't it do as well in this case?
Well, self-consistency is kind of relying on those initial probability assessments.
Right.
And as we've talked about, those can sometimes be off.
Yeah.
Without any prompting, the LLM might just go for the most frequent answer, even if it doesn't really make sense.
So it might not be able to tell the difference between being confidently right and confidently wrong.
Exactly. It needs that extra guidance.
Yeah, like that prompting to kind of nudge it in the right direction.
And when you add prompting to the mix, self-consistency works much better.
Okay. So it's all about setting up the right conditions.
Yeah, I think that's a really key takeaway.
And CoT-decoding, whether on its own or with prompting, seems to be a great way to do that.
Absolutely. It really helps to ensure that robust reasoning.
This all makes me think about how important it is to look beyond the surface.
Yeah.
To really understand the how and the why of how LLMs get to their answers.
It's not enough to just look at the output.
Exactly.
We need to understand the process.
It could change everything about how we approach LLMs.
I think it will.
How we develop them, train them, use them.
This research is definitely pointing us in a new direction.
Yeah.
It's exciting.
It really is. So what does all this mean for the future of LLM research?
I think it opens up a lot of really interesting possibilities.
Okay.
It tells us that we need to focus on more than just making these models bigger and faster.
Okay.
We need to figure out how to improve their reasoning abilities.
Like targeting that specifically.
Yeah.
Not just hoping it emerges as they get bigger.
Exactly. We need to be more deliberate.
So moving from just focusing on those benchmarks to understanding their cognitive processes.
Yeah. And it's not just about mimicking human thought.
Right.
It's about figuring out how they can reason in their own way.
So maybe creating new architectures.
Yeah.
Or new training techniques.
That really target those challenges like state tracking and multi-step reasoning.
Yeah, and thinking carefully about the data they learn from.
Absolutely.
If we want them to be truly intelligent, they need to experience complexity.
Right. Not just simplified examples. Yeah. It's like we need to give them a real education.
That's interesting, like creating a curriculum for LLMs.
I love that idea.
So starting with simple stuff and getting progressively harder.
And maybe even incorporating some kind of feedback mechanism so they can learn from their mistakes.
It's like building a reasoning gym.
That's a great analogy.
Like they can practice those skills.
I like it.
This paper gives us a really great starting point.
It does.
For figuring out how to train them.
I'm really excited to see where this research goes.
Me too. It's not just about making them perform better on tests.
Right.
It's about building systems that can understand the world.
Yeah.
And reason about it in a way that's both reliable and beneficial.
That's the ultimate goal.
This has been a really thought-provoking deep dive.
It has.
Into LLMs and their ability to reason.
A lot to think about.
We've covered a lot.
We have.
But I feel like we've only just scratched the surface.
There's always more to learn.
If you're interested in learning more, I highly recommend checking out the full paper.
Yeah, it's a great read.
It's packed with details and insights.
Absolutely.
I want to leave you with one final thought.
Okay.
The researchers in this paper focused on exploring branching at the first word the LLM generates.
Right.
What if we thought about branching at any point?
That's a really interesting question.
It would be a huge computational challenge.
Yeah.
But it could reveal some really complex and unexpected reasoning paths.
It could change everything about how we understand these models.
This deep dive has definitely given us a lot to consider.
It has.
It's an amazing time to be following this field.
It really is.
And who knows what breakthroughs are coming next.
I can't wait to find out.
Thanks for joining us.
Thanks for having me.
And until next time, keep exploring, keep questioning, keep pushing those boundaries.